Happy Monday, guys. All right, so this week we're going to be starting to solve equations. I know some of you have already started this, and if you have, great, you've got a head start. If you are new to this, don't worry. I just want you to follow along with the directions I give you. So last week I gave you guys some practice on expressions. And today we're going to build on that. So I'm going to start you guys off with just a reminder of what an expression looks like. So an expression might be a problem like x plus 3. So a math problem with no answer. So today what we're going to be doing is we're going to be kind of adding on to an expression and making it into an equation. So the difference between an expression and an equation is that an equation has an equal sign. So what this means in terms of a problem is that it might look still like x plus 3, and then I give you what it should equal. So let's say I say x plus 3 equals 7. So expression, no equal sign. Equation has an equal sign. Now the cool thing about equations is that we can actually solve them. And that's our goal always. We always want to solve them to find out what the letter stands for. Now the way we do that is there's something very special, and I'm going to refer to it a lot. You'll hear this in the future as well. It's called opposite operation. Okay? The opposite operation is what we are going to always use to find the answer to an equation. Opposite, you guys know what that is, and operation means what kind of math problem are you doing. So let's say I was doing an addition problem. The opposite of an addition problem would be a subtraction problem, and vice versa. If I have a subtraction problem, the opposite is addition. Those two will be used together to help us solve. Same thing with multiplication. If I have a multiplication problem, the opposite is division. And if I had a division problem, the opposite is multiplication. All right, so these opposite operations are going to be key to help us solve an equation. All right, so I kind of mentioned already, but I just want to reinforce that our goal today when we are solving equations is I want to get the variable alone. Variable, we talked about that last week with expressions. That means the letter. I want to get the letter or the variable alone. Okay, I really want to find out what the variable stands for. So let me start you off with a problem. I've got a plus 5 equals 12. All right, so my goal is to get the letter all by itself. Now the way I have to do that is I have to use my opposite operations. So right now I see that I have an addition sign in the problem. And again, I want to get a by itself. So I'm kind of thinking of this as there are two sides to the problem, and it's split by the equal sign. And I need to get a by itself, which means I need to get rid of this plus 5. And again, the way I'm going to do that is I want to do the opposite of adding 5. And we said up here that the opposite is to subtract. So what this means is instead of adding 5, I'm going to subtract 5. And what I do to one side of the equal sign, I have to do to the other. That's always going to be a rule moving forward in math. Okay, now what happens here is this plus 5 and minus 5, what we say is they cancel each other out, which means they go away. Now it looks like magic, you can kind of think of it like magic, but really if I had 5 things and I took 5 away, I have nothing left, which is my goal. It's to get rid of that altogether. Now what I do have left over here though is the letter A. And now if I solve the other side of the problem, I can find out what A should stand for. So I've got 12 minus 5, which makes 7. So unlike expressions where we didn't really get an answer like this, today with the equations, you're always going to find an actual answer. Okay, so that was the first one. Let's try another one just to get the ball rolling. All right, so this time I have x minus 3 equals 13. Again, a trick that I always use is I always draw a line down the equal sign to remind myself there are two parts to the problem. And again, my goal is to get the letter all by itself. So when I look at this problem, I see that there is a minus 3, and my goal is to get rid of that by using my opposite operation. So opposite of subtracting is to add, and I need to get rid of the 3, which means I'm going to add 3. What I do to one side, I do to the other side of the problem. And right here, my opposites, they cancel out. They become a big fat 0. Now what I'm left with is the letter x on one side. And on the other side of the equal sign, I can now add those two together. 13 plus 3 equals 16. And again, that's my answer. Now, one thing I do want to show you just before I move on is that you can actually check to make sure that your answer is actually accurate. You could always check these answers, which is really cool about equations, because you can know for sure if you got the answer correct or not. The way that you do a check in this case is you go back to the original problem. So I've got a plus 5 equals 12. And let's say I just want to double check, just make sure I actually did the problem correct. I can take my answer that I got here and put it into the problem, kind of like when we were solving expressions. So instead of an A, I'm going to fill it in with the letter 7 plus 5 equals 12. And then I ask myself, 7 plus 5, does it equal 12? If it does equal 12, then I know I did that problem right. If I got it wrong and it doesn't equal 12, then I can go back here and check my math. Now again, you're not required to do that for every problem, but that is an easy trick that you can always use that will guarantee that you get the problem right every time. Okay, let's try a couple more like this, and then I'll move on to one other thing that I have to show you today. All right, so I've got k plus 6 equals 18. Again, my goal is to get the letter all by itself, and I have to do the opposite of what I see. So right now I see I have plus 6. Opposite of addition is subtraction. And I have to do the same thing to each side of the problem. So I subtracted 6 to each side instead of adding 6. My opposites cancel out, they go away. I am left with the letter K on this side, and all I have to do is solve the subtraction problem on the other side. 18 minus 6 leaves me with 12. Again, that's my answer. I was able to find one number that equals the letter, and I can check it just to make sure if I don't know if it's correct. All right, and one more like this. I have m minus 8 equals 24. All right, again, my goal is to get the letter all by itself, and I need to do the opposite of whatever I see in the problem. Here I have a minus 8, and the opposite of subtraction is to add. I'm going to add 8 to each side of the equal sign. My opposites cancel out. The minus 8 and plus 8 go away. I'm left with the letter M, and I need to add these two together, and when I add them together, I should get an answer of 32. All right, so that is just solving an equation with addition and subtraction. So we only had to add or subtract to find the answer. Now, we do have to use multiplication and division, which we have up here as our opposites. So I'm going to continue with that on my next page of my notes. All right, so here's a problem for you that looks a little bit different, but the goal is always the same. Get the letter all by itself. Okay, so I've got 5b equals 30. Now you might be thinking to yourself when you look at this, there is no operation. Like it doesn't say to add, subtract, multiply, or divide in there anywhere. But if you remember from class, there's always invisible multiplication sitting in between two things that are right next to each other, like a letter and a number. So this is actually multiplication, and I have to do the opposite of multiplication to find the answer. So I hope you know that the opposite of multiplication would be division. And if my goal is to get the letter B all by itself, I have to get rid of whatever is there with the letter B, which would be the number 5. So instead of multiplying by 5, I'm going to divide by 5. And what I do to one side, I have to do to the other side. All right, now these two cancel each other out. Just so you know, 5 divided by 5 doesn't equal 0 like we saw on the other side. It does still cancel itself out, but 5 divided by 5 makes 1. So this means really I'm left with 1b at the end, which is good because I wanted to get that letter all by itself, and having one of them is my goal. All right, so those two cancel each other out, and then I come over here, and again, I'm going to solve that problem. So 30 divided by 5 makes 6. Again, I could do a double check if I wanted to on this. So let's say I just wanted to make sure I got my answer correct. To check this problem, I start with 5b equals 30. I am going to take the answer to b and fill it in there. And I remember that I've got my invisible multiplication right there in the problem. And I know that 5 times 6 does equal 30, so I got that correct. All right, let's try another one like that. So this time I'm going to give you 3x equals 36. Again, my reminder is that there is always invisible multiplication in between a number and a letter. All right, and my goal is to do the opposite. So if I have invisible multiplication, the opposite would be to do division. And since my goal is to get the letter all by itself, I have to get rid of anything that is next to the letter. So my goal is to get rid of the number 3 by doing the opposite, which is to divide by 3. Multiplying by 3 and dividing by 3, those two cancel each other out. They go away. I am left with an x. And again, I am going to do 36 divided by 3 to find my answer, which is 12. You are always free to use your calculators for this as well. So if you are having a little bit of trouble, as long as you're doing the steps and you just need to use a calculator at the end, that's okay. All right, that was one set of problems. Now let me show you one other kind that you will see in your practice this week. So let's say you see a problem that looks like this. All right, so now again, I've got to, like, the first step that I always want to think to myself is what am I doing here? Am I adding, subtracting, multiplying, or dividing? Now this problem looks a little bit funny, but this bar right here, you're going to see it as we move into higher level math. That little bar that makes like a fraction means that I am dividing. Okay, so now that I know that I'm dividing, I have to do the opposite of division to get my letter all by itself. The opposite of division is to multiply. And if my goal is to get the letter x all by itself, I've got to get rid of this 10 that's hanging on there, which means instead of dividing by 10, I am going to multiply by 10. And I have to do the same thing to each side of the equal sign. So right here, it's kind of like this division or the fraction bar, dividing by 10 and multiplying that by 10. Those two are going to cancel each other out. They go away. I am left with the letter x. Now on this side, I have to do 7 times 10 to find my answer. 7 times 10 makes 70. And again, that would be my answer. And I can check it just like I did above here to see, did that actually work? All right, so let me show you another one like that. This one is going to say r over 4 equals 8. All right, so again, whenever I see this fraction bar, that means that I'm doing division. in class before with anybody that's tried this. I know I just added those little dots in case some of you liked that, just as the reminder that that fraction bar means division. All right, now the opposite of division is to multiply, and my goal is to get the letter all by itself, which means I have to do the opposite, or I have to get rid of anything that isn't the letter R, which is the number 4. So here I am going to, sorry, Matilda wants to come and say hello to everyone this morning, of course. So instead of dividing by 4, I multiply by 4, which means that my opposites here cancel each other out. They go away. I'm left with the letter R. And then all I have to do is solve on this side, which means 8 times 4 equals 32. And that would be my final answer. Again, I can always do a double check with that, just like I did above here in green, just to make sure that that actually does work out. All right, I know I keep saying like one last thing, but there's one last thing, very last thing. So far you guys have seen how to solve an equation when you have to add, subtract, multiply, and divide. There's one last one that you will see. You can't get rid of fractions. Like, you can never like hide from them. You can get rid of them, but you can never hide from them. They will always come back to you. Okay, so right now I'm going to give you some problems that have actual fractions in them. And your hint, so that you can get rid of a fraction, is that you're going to use the reciprocal. And if you watched any of our videos from a couple of weeks ago about fractions, you would have been reminded of that word reciprocal. And reciprocal, remember, just means flip the fraction. Okay, so how does that apply? Let's take an actual look at one of the problems. All right, so here I've got the problem. 5/6 x equals 20. Okay, so the reason I said that when I have a fraction, I'm going to use the reciprocal is because even though I've got a fraction here, it easily goes away when I flip it. And maybe I'll add and multiply. So the way I get rid of this fraction, because my goal, remember, is to get the letter all by itself, I want to get rid of the 5/6. The way to get rid of it is to flip it and multiply. So what I'm going to do here is I'm going to put my multiplication sign. Notice I used a dot instead of an X, just because I have the letter X in there. The dot means multiply 2. And I'm going to flip the fraction upside down, which means I'm going to do 6/5. Now, the cool thing about this is if you guys actually did your multiplying the fractions together, you would get 30 on the top. 6 times 5 makes 30. You'd get 30 on the bottom, and 30 divided by 30 makes 1, which again makes these actually cancel out. Now I'm going to do the same thing to the other side. Exact same thing that I did in green. I'm going to multiply by 6/5. All right, so over here so far, I've canceled everything out. I have the letter all by itself, which was my goal. Now on this side, I'm going to multiply these fractions together to see if I can find an answer. And if you forgot how to multiply fractions when it looks like there's a whole number, I turn 20 into a fraction by putting a 1 at the bottom. And I'm just going to multiply straight across. If you're not sure how to do this in your head, 2 times 6, you can do the answer to that and then add a 0 to the end. 20 times 6 makes 120. 1 times 5 makes 5. And in this problem, I need to still make this fraction smaller to get an actual answer. Now from our division hints sheet, if it ends in a 0 or a 5, I can actually divide it by 5. But really, I want you guys to think about like just plugging that into a calculator. 120 divided by 5 is really all you have to do. And if you do that, you should get a big answer of 24. Okay. All right, let me show you one more with fractions. I know fractions are going to be the ones that are the trickiest for you guys, but I don't want you to be afraid because the fractions really will disappear when you use the reciprocal. All right, so here's one last one for you. I have 2/3 x equals 12. Okay, so again, I'm going to draw that line down my equal sign to separate the two sides, and my goal is to get x all by itself. Now, to get rid of the fraction, I am going to flip and multiply. So I'm going to put my multiplication sign here. I'm going to flip the fraction upside down. That means that the 3/2 and the 2/3 go away, and I'm left with x. All right, then on to the other side. I have to do the exact same thing I did in green. I'm going to multiply by 3/2. And again, right now I've got a fraction and a whole number multiplying together, so I'm going to turn 12 into a fraction by putting a 1 on the bottom. Now I'm going to multiply straight across. So I've got 12 times 3, which makes 36, and 1 times 2, which makes 2. All right, and now my goal is really to do 36 divided by 2, cutting 36 in half, which makes 18. Most of the time when you guys do these problems, your answers are going to give you either a whole number or maybe a decimal where it's like a half, like 18.5. You're not going to get crazy answers where the decimals repeat or never end. So keep that in mind when you're doing these. Again, that's why I said you can type that into your calculator as 36 divided by 2 to get your answer. Okay, now I've got a practice worksheet and a Google form so that you can submit your answers to me today so that I can take a look at them. And I changed our schedule from our practice week last week a little bit. Tomorrow at noon, to give you guys time to sleep in and try the work, I will be on in a Zoom call with you guys, and I'll go over any questions that you had from the practice worksheet so that you can ask your questions and get some answers. And send me some emails if you guys need some help. All right, see you tomorrow. Bye.